Hello everyone, meteorologist Danielle Juliano joined by meteorologist Mark Collins, and we are going to do a recap of the Webb Telescope here because we got in some amazing images this week, Mark.
Yes, this is really incredible for all of humankind to see these type of pictures coming from space. It's a space telescope. It's been launched because it's outside of the atmosphere of the Earth, so you can see better, more details of the stars, the planets. But what's remarkable is this was the first picture that came back, and it was given to President Biden before the rest of us could see it, because it really is the hallmark of the Webb telescope. What you're looking at is called the deep field image. It's basically showing the entire cosmos, and what you're looking at are the stars, or the galaxies, I should say, that are closer to us in white. The ones that are much farther out in space are red, and light travels to us in a fixed speed, and based on that, we can determine how far out these galaxies are, and they're about 13 billion light years away. So
that is just crazy.
It's remarkable here to see that.
And this photo, this is the Karina Nebula. It is absolutely stunning, and you can actually compare this photo to the one that was taken by Hubble, the Hubble Space Telescope. And right now you can see the previously obscured stellar nurseries beyond the gas plume there, which is really cool.
This is where the stars form. These are the early incubators, and you can see that it looks like a star, but that's actually a diffraction spike. So when these telescopes are in space, they have mirrors, and they're in the shape of a hexagon, so it's six-sided, and you'll see six spikes where the light bends around the edge of the mirrors. Now, one way to tell that this is not the Hubble one is because they have four spikes. It's a square mirror.
So Hubble's square, so it'll have four spikes.
Right. The
Webb
will have these six
spikes on it. Okay, so
but it does look similar to one of the Webb
images there.
Yes.
Yeah, very beautiful. And this is what, the southern ring, 2,000 light years away.
A little bit closer than the ones that we just saw at the beginning. But so when a star is at the end of its life, it will basically explode, and becomes a white dwarf, and the gases that are given off are shown here in blue, and they're ionized gases. And this is actually so detailed that you can see on the right image, it's a binary star. So there's a star at the middle there, and there's two of them, and so they're interacting. Pretty cool picture.
And what's the difference between these two images?
To different resolutions. There. So the red shows a lot of the dust. So it's basically revealing the dust along with the gases in the sky.
Because the one on the left is extremely detailed.
Yeah, it looks like an eye, like the eye of the universe is looking back at us.
Staring right at you, Mark.
So we showed you the nursery, and that was where, and then that last photo was where stars go to die. So this is Stephen's quintet. These are just 5 different galaxies. So there's 1, 2, 3, and 4, and 5. 2 galaxies.
Yeah, they're right next to each other right there.
And so they're interacting with each other. And what you can't see is a black hole. You'll never be able to see a black hole. We'll never be able to photograph or measure a black hole, because it's where all of mass gets sucked into and light can't escape. So that's why you can't see black holes.
Isn't it crazy though? It says black hole 24 million times the mass of the sun. If you can only really imagine how large that is. That is crazy. And going along the terms of crazy, we have some fun facts this week to round out the week with the Webb telescope here. So Mark, start us off. What is fun fact number 1?
All right, this is pretty cool. It sees clearly a penny that would be 24 miles away. So imagine.
I don't even think I can see a penny towards the end of this room. Like, it'd have to be like on the floor in the other room, but 24 miles away.
Right. That's better than my binoculars at home. That's for sure. All right. So what's next here?
The next one we have here are the mirrors on the hexagon are plated in 24 karat gold. And if all that gold was technically melted down, it'd only be the size of a golf ball. So it's very, 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 very thin layer of gold.
Many different mirrors on the telescope, and they're about 21 feet in diameter. There's a lot of gold plating there.
That is a lot of gold
plating. But those mirrors, when they're very clean, they can reflect the light in a way that allows us to see the astronomers see so far away.
Oh, 100%.
All right, so this was new. So this actually spotted an exoplanet, and it detected water vapor on that planet. The problem is it's super hot, this particular planet that they found. But where there's water, there could be life, and that's what's interesting. If it were a rocky planetary body with water, maybe there could be extraterrestrial life. But this particular exoplanet that they found is massive. It basically revolves around its star in 3 days. It's big like Jupiter. So because it's so big, it's very dense and it heats up, and it's like 9,000 degrees.
Ooh, a little too hot for me. And speaking about temperature change, the instruments on the Webb telescope can function at almost 459 degrees Fahrenheit below zero, which is absolute zero, which is
very close to
explain what
zero.
that is really.
So that's when all molecular motion ceases.
Ooh,
so it is
a little
so
too cold for me.
That it's like 0 Kelvin. So at that point, physics starts to break down, kind of, and that's cold. So you got the hot stays hot, the cold stays cold, just depending on which side of the thermometer or the telescope you're looking at.
Speaking of sides here, this last one's interesting. One side is as hot or hotter than Death Valley, and the other side of the telescope is colder than Antarctica. Talk about hot and cold there.
Yeah, that's crazy. I just can't imagine the engineering that goes into the material design to be able to have that thermal leeway. You know, what type of materials must they use that could survive something so hot
a lot of research.
and so cold? Brilliant people, right?
Brilliant people. All right, well, thank you for joining us today. You can find more on the Webb telescope on news4jax.com.
Bye-bye.